Okay, if we were in class today, I would have given you a sheet that looked like this with a question on it, an example of a torque ladder problem finding the mass. Wouldn't have the solution on it though. So it's what I'd like to do with you right now. So it says a 10 kilogram, 12 meter long uniform ladder is leaning against a building, creating an angle of 60 degrees. So let's do it over here. Okay, so here's my ladder. 12 meters long, creating an angle of 60 degrees. And the question on this sheet, it's a little blurry, but the question tells us the mass of the ladder is 10 kilograms. Okay, bringing back the non-blurry sheet. A student makes it 3/4 of the way up the ladder before it slips. If there's no friction between the top of the ladder and the building, the coefficient at the base is 0.4. Oh, and there's an error in the question. What must, not in this one though, what must the mass of the student be? Okay, so it's a uniform ladder. So here's FG of the ladder. FG of the student is somewhere along here. There's an F normal of the ground. An F friction of the ground. An F normal of the house. It tells us the student makes it 3/4 of the way up, and it tells us the coefficient is 0.4, and we're looking for the mass of the student. Okay, so if we do sum of the forces in the y direction equal to MAY, which will be 0, we'll have F normal of the ground minus FG of the ladder minus FG of the student will equal 0. So F normal of the ground is equal to, taking them over, M of the ladder G plus M of the student G. This time, even if you wanted to, you cannot find this value because you don't have the mass of the student. So go to the x direction. Sum of the forces in the x direction is equal to MAX, which is 0. And again, there's 2. There's friction on the ground minus normal of the house equal to 0. Okay? And so that means that the normal of the house is equal to the friction on the ground. And we know that friction is equal to mu ground, Fn ground. So that means the normal of the house, if we plug this in, is equal to mu brackets M of the ladder G plus M of the student G. But we can't find this because we don't have the M of the student. We have everything else. So don't fill your numbers in. We're going to sub it when we do sum of the torques. So we go to sum of the torques equal to 0. And again, normal of the ground, friction of the ground, normal of the house, the ladder, and the student. Again, I would suggest pick your pivot point here. So this one goes to 0, this one goes to 0. Holding it down at the pivot point, the normal of the house is going to cause it to rotate counterclockwise, which will be positive. The 2 weights clockwise, which will be negative. So positive, negative, negative. So R normal of the house, F normal of the house, sine theta normal of the house, minus R of the ladder, FG of the ladder, sine theta of the ladder, minus R of the student, FG of the student, sine theta of the student equals 0. Okay, but normal of the house is this whole dude. So where normal of the house is, down here, let's plug in that. Okay, so it'll become R normal of the house, bracket, mu, M of the ladder G, plus M of the person G, close the bracket, sine theta normal of the house, minus R of the ladder, M of the ladder G, sine theta of the ladder, minus R of the student, M of the student G, sine theta of the student equals 0. And I think I used person here, so let me change that to an S. Okay, we're trying to solve for mass of the person, and it's in 2 spots, here and here. And in the first one, it's stuck inside the brackets, so we need to expand the brackets. Now, when you expand the brackets, notice there's an r and a mu in the front and a sign in the back, and they have to go to each of the m terms. So be careful. R normal of the house, mu, m of the ladder, g, and then this sine theta has to get distributed to sine theta normal of the house. Plus, the next term gets an r normal of the house, a mu, an m of the student, g, and again, sine theta normal of the house. And this is why subscripts are important, because look, now they're not all the same in a given term. So please put your subscripts in. Minus r of the ladder, m of the ladder, g, sine theta of the ladder, minus r of the student, m of the student, g, sine theta of the student. Angles are not all 90 and are not all the same. Okay? But there is a g in every term. So because there's a g in every term, we can cancel, 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 cancel. And we're looking for m of the student, so keep the 2 with m of the student on one side and take the 2 without the m of the student to the other. So r normal of the house, mu, m of the student, sine theta normal of the house, minus r of the student, m of the student, sine theta of the student, because remember I canceled the g's, equals the r of the latter term will become positive when I take it over, and his other front term will become negative. R normal of the house, what was it? M mu, m of the ladder, sine theta normal of the house. All right, pull out your m of the student. So r normal of the house, mu, sine theta normal of the house, minus r of the student, sine theta of the student will equal everything on that side that doesn't change. Divide by the bracket. So on top will be r of the ladder, m of the ladder, sine theta of the ladder, minus r normal of the house, mu, m of the ladder, sine theta normal of the house, and then the bracket on the bottom, r normal of the house, mu, sine theta normal of the house, minus r of the student, sine theta of the student. Okay, so now all that's left is, can we fill the right numbers in the right spot? R of the ladder, it was a 12-meter long uniform ladder, so R should be 6 meters. Mass of the ladder was 10 kilograms, and the angle, it said it was 60 degrees, down here at the bottom, so this should be 30 up there. So sine of 30 minus R normal of the house should be the full length of the ladder, which is 12 meters. The mu they told us in the question was 0.4. Mass of the ladder, 10 kilograms. And then this angle is the angle for the normal of the house. The angle at the bottom is 60. Then this one up here must be 60 also. So it's going to be 60 degrees. Okay, so please notice the angles are not all the same. Dividing by R normal of the house, which we just said was 12 meters, mu, which is 0.4, and sine normal of the house, we just said was 60, minus R of the student. And it said the student was 3/4 of the way up a 12-meter long ladder, so that should be 9 meters. And sine of the student, the angle between the R of the student and the F of the student is this guy, should be the complement to 60. It should be 30 degrees. And now you need to carefully punch this into your calculator. Okay? And it should, this first term I think is 30 meter kilograms minus 41.5692 meter kilograms on the top. The bottom 4.15692 minus 4.5 meters. That's just in case you get messed up. Punching it in, 33.7218 kilograms. Okay, is the answer. Homework On the back of your sheet, the next two